we invite our next speaker, Professor Ludmila Badsmanova. Please welcome.
Good morning. I'm a junior researcher Ye.O Konotop from the Laboratory of Plant Productivity from Kiev, Tarasovchenko National University. Sorry. I will present to you some practical implementations we get in collaboration with our colleagues from University of Life and Environmental Science of Ukraine. According to United Nations projections, the world populations could reach 9 billion people by 2050, creating a 60% increase in demand for food. Moreover, crops may also be used increasingly for bioenergy and other industrial purposes. The Intergovernmental Panel on Climate Change predicts that the global warming will reduce agricultural yield by 2% per decade. Agricultural productivity in the next 60 years also doesn't seem to be uniform in the world. Also today, roughly 1/3 of the food produced for human consumption is gets lost or wasted. So to meet tomorrow needs, we are clearly going to learn how to feed more people with less land in a more sustainable way. The major factors causing food scarcity abiotic and abiotic stresses such as plant pathogens, limited drought, flooding, nutrient deficiency or toxicity that substantially limit crop production worldwide. It is estimated that abiotic and biotic stresses collectively contribute more than 50% of crop losses. A survey conducted by Bayer in 2008 indicated that crop losses caused by stresses were significantly greater than the average yield of economically important crops such as corn, wheat, soybean, millet, oats, and barley. Therefore, there is a dire need to devise methodologies to enhance crop production, particularly in the stressed region of the world. In present research, we have mainly focused on nutrient base of crop development and recent approaches that could be used for crop improvement under environmental stresses. World fertilizer consumption has increased for the last decade, and it is expected that this upward trend will continue. For example, in recent years, consumption of nitrogen fertilizers has increased to 9% only in our region. However, the danger that causes surplus of fertilizers in soils should be considered also. Harmful effects of chemical fertilizers include increased waterway and air pollution, soil acidification, mineral depletion of soil, nitrogen pollution that directly or indirectly increase atmospheric warming and climate change. One of the solutions could be the attraction of new nano-sized materials and technologies based on their use. Nanotechnology as a branch of nanoagriculture focuses currently on target farming that involves the use of nano-sized particles with unique properties, provides new agrochemical agents and new delivery mechanisms to improve plants' adaptive potential and crop productivity, and promises to reduce pollution caused by high doses of mineral fertilizers. The aim of the present research was to study the effect of colloidal solution of nanoparticles of metals, iron, manganese, copper, zinc, and argentum on soybean to determine the prospects for their use in agrotechnology. Objectives of our study were optimization of way of application of colloidal solution of metal nanoparticles, determining of effective concentration of metal nanoparticles for increasing soybean yield. Conditions of the field experiment were the following. We used fields of the Department of Crop Growing of National University of Life and Environmental Sciences. Ultra early and early maturing cultivars of soybean recommended for forest steppe ecoregion of Ukraine, Anushka and Usta respectively were used. We used common agricultural technology for soybean cultivation in northern forest steppe ecoregion of Ukraine, and all experiments were performed triplicate. Properties of patented stock complex of colloidal solution of metal nanoparticles is presented on the table. Current literature revealed that uptake, translocation, and accumulation of different nanoparticles in plant organism are dependent of species of plant and special properties of the nanoparticles such as size, chemical composition, and stability. Most metal-based nanoparticles were found to be taken up and accumulated by plants. However, the published data concerning biotransformation of nanoparticles in plant organisms is still not conclusive. Colloidal form of nanometals were received in electric conductive layer by dispersing in water. Processing of nanoform of biogenic metal colloidal solution and its physical properties was determined at the National University of Life and Environmental Sciences and is confirmed by several patents. The basis of the process of obtaining nanoparticles is electric treatment of granules of iron, manganese, copper, zinc, and other metals. Field experiment. Two experiments were conducted to determine the effectiveness of the solution of metal, of colloidal solution of metal nanoparticles for soybean yield. First experiment was focused on assertion of the best way of application of colloidal solution of metal nanoparticles for soybean cultivations for both cultivars. We tested two types of application. It was pre-sovereignty treatment and pre-sovereignty treatment with additional foliar spraying in budding and flowering phases. Sorry that it's not visible. Other options, each options includes untreated control and application with colloidal solution of metal nanoparticles in different concentration, 120 and 240 milligrams per liter. Yield of soybean dependent on way of application of colloidal solution of metal nanoparticles for both cultivars, and the highest productivity was obtained after the treatment after the double treatment with colloidal solution of metal nanoparticles. It was pre-sovereignty treatment and foliar spray in flowering phase. And the highest yield was at the level of 2.4 and 2.39 tons per hectare. So we could recommend the concentration of colloidal solution of metal nanoparticles for seed processing 240 milligrams per liter with consumption rate of 0.1 liters per ton of seeds, and the same concentration was favorable for increasing soybean yield by foliar fertilizing of soybean. The second experiment was focusing on comparing the use efficiency of different concentration of the solution of metal nanoparticles with traditional fertilizers for soybean for ultra-early cultivar Anushka. As previous experiment, it was 3 years field experiment. Different nutritional rates were used for the experiment, granular superphosphate and potassium salt in doses 30 kilograms per hectare, and different doses of ammonium nitrate, 30, 60 and 90 kilograms per hectare were contributed during the primary tillage. Other experimental options were untreated control, seed treatment and seed treatment with foliar spraying by multi-component solution of metal nanoparticles in concentration 120 milligrams per liter, and the same application in concentration of colloidal solution 240 milligrams per liter. Yield of soybean of cultivar Anushka was dependent on the concentration of complex multi-component solution of metal nanoparticles as well as nutritional rate. But the highest productivity of soybean was obtained after the treatment, after the double treatment by a complex multi-component solution of metal nanoparticles. It was preserving seed treatment and foliar spraying by solution in concentration to 140 milligrams per liter, and the highest yield was obtained with a nutritional rate of nitrogen 60 kilograms per hectare. So concentration 240 milligrams per liter of multi-component solution is recommended for seed and crop treatment of soybean for common cultivation of soybean, and treatment of soybean by multi-component solution of metal nanoparticles in concentration 240 milligrams per liter was the most effective with nutrition by traditional fertilizers in the rate of nitrogen 60 kilograms per hectare. So let me conclude my presentation that we get that multi-component colloidal solution of metal nanoparticles influences the physiological processes of plant organisms that led to improvement of crop production of soybean cultivars. Colloidal solution of metal nanoparticles assist to augment the activities of traditional fertilizers, and multi-component colloidal solution of metal nanoparticles is recommended for preserving seed treatment and foliar spraying in budding and flowering phases during cultivation of early maturing soybean cultivars in low humus containing black soil or forest deep ecoregion of Ukraine. Thank you for your attention.
Thank you, dear speaker. And one question, if someone has. Yes, please.
Our previous research on a standard test object with allium cepa showed that it could be toxic in some concentration, but not each metals. And in such combination we used, there was no toxic metal nanoparticles in this solution.
Okay, thank you.
Thank you.
So with this I close the session, and I would suggest we have reasonable 5 minutes for a coffee break, and then I pass it here to Professor German Telvis, and the section will be headed as nanostructured surfaces. So you're welcome for a coffee.